Hello.
Bueno, vamos a esperar a que el doctor Saxena vuelva a conectarse. Tiene problemas de conectividad. Esperemos.
Do I model? Okay, shall I start?
We can see your presentation, but
See, I have some internet. I have some net problem, so I will continue without opening my video so that it will take less data for buffering. Is it okay?
okay.
Yeah, doctor, it's fine.
Dr. Amit, no problem. Please go ahead.
Okay, thank you, Ganesh. See, my topic for the presentation is recent development in polymer electrolytes for rechargeable batteries. Myself, Dr. Amit Saxena. I am from Shri Vaishnav Vidyapit Vishwavidyalaya, Indore, India. Very initially, I will keep my topic, my presentation very fundamental for the UG and PG level students. Although professor previous to me, my presentation has discussed large about batteries. He explained the performance and the important parameters of battery in great detail. But now I restrict my presentation only to the one of the important parameter of battery, important component of battery, which is a polymer electrolyte. So I keep my presentation very close to the area on say the historical timeline. All we say the battery of polymer electrolytes, idea of battery was around 4 or 5 decades back. But the Indian mythology, which is well given in Agastya Sahita, they have mentioned the idea of battery now. The Sanskrit version of the entire thing. I'm not narrating these Sanskrit words, but the meaning of this entire word, which is given above, is there's a well-cleaned copper plate, cover it with a copper spit, and then by moist solder. After that, put a mercury on top of dust to polarization. The contact will provide an energy known as with Varuna. Water will be split by its current into pranayam and udayan. That is the oxidation and reduction reaction. 100 to be the effective force. The concept of the battery or the electrochemical cells open around year back of 400 to 4000. Now, trying to elaborate the same idea of electrochemicals, there is an electrochemical system is comprised of containing electrolytes, which electrodes are dead. The same statement was given around 4,000 back. The construction and working of the electrochemicals. Electrodes are connected by first-class conductor either with a source of electric current during electrolysis, a chemical fan or electrode during passage of electric current, and electrolyte cell of flow produces chemical reaction. in a galvanic cell, electric current is generated in consequence of electric chemical reaction also. This is a short introduction about the idea of battery, and already the professor discussed large about the battery functioning out. Basic concept of ox reaction, where reduction and oxidation process going on. During the reduction means a reaction during the with electrons are being consumed, right? And the side, when oxidation process goes on, we get the free electrons, and these free electrons actually across the electrode do the conduction part, and we find the current across the connections, right? The atom or molecules use electron is known as reducing agent, while which accept the electrons are an oxidizing agent. This is a very fundamental idea about the electrochemistry. Okay, the electrochemical cells are basically classified into parts: photovoltaic cells and the electrolytic cell. We are interested with the photovoltaic cell, where we have the two where we have the copper dip electrode and zinc electrode. We have the salt bridge, and I think all UG and PG students, even the higher studies, the PG students have the idea about this all working, how the electrons start flowing through the structure. The batteries, which is around 1749. Benjamin Franklin was the person who first coined the word battery to describe and the link capacitors used for the experimental purpose. And from that point, we have gradually have a number of research and discoveries in the area of batteries. Already professor discussed a lot about the battery and all. So I will quickly come into the important the factors of your important component of your battery. So this is a primary cell. If you divide your primary cell and secondary cell, primary cells are which are non-rechargeable and disposable. Chemical reaction use cannot be reversed. Used in long period of storage are required. Charge rate and smoke detection, flashlight, remote control. These are some uses which we use. Might be we all go through these applications. So secondary cells are our prime interest. Nowadays, so many work are going on the area of secondary cells, that is the rechargeable batteries. And when we are coming into this area of rechargeable batteries, we are more interested about the electrolytes, where the ions are actually moving across the electrodes, across the anodes and cathodes, how the ions are moving across these anodes and cathode, and how we are getting the amount of current, right? So when we are coming to the major components, so these are the major components: anode, cathode, and the electrolyte. About anode and cathode, a large, huge discussion was done by the professor. And this is the anode is a negative or reducing electrode that releases electron by the external circuit. Cathode is a positive or oxidation electrode that acquires the electron from the external circuit. And electrolyte is something which is more interesting, where the ions transport take place. With the mechanism, ion transport between the two electrodes are taking place. And the electrolytes are thought of liquids such as water or other solvent dissolves like salt, acids, alkalis that are required for ion conductions. And these are very popular size of batteries: AA, AAA, and D. All batteries contain solid electrolytes that acts as ionic conductor at room temperature. So these are few important properties which has to be exhibited by the material. Like if we are discussing about anode material, it should be efficiently reducing agent, high coulombic output, good conductivity, stable, ease of fabrication, low cost. Metals such as zinc and lithium are often used as anode material. While for the cathode, the following properties has to be offered by the cathode material: the efficient oxidizing agent, stable when in contact with the electrolyte, useful working voltage, ease of fabrication, again low cost, and metal oxides such as used as cathode materials. The most desirable cathode anode materials combination that result in cells with high voltage capacity. Like previously, a professor answered this question when someone asked what are the properties for a battery. So voltage and capacity is one of the very important parameter for the effective working of a battery. Right? Now, we are interested in electrolyte. So electrolyte should achieve the following property: strong ionic conductivity. This is one of the most important part which we want. This should be very, very high ionic conductivity. No electrical conductivity. That is, it may be serve as the purpose of separator also. It can serve the purpose of separator also. Non-reactivity with electrode materials. No corrosion and all. Properties resistance to temperature fluctuation. Safeness in handling. Again, low cost. Solutions as dissolved salt acid often used as electrolyte. So the traditional batteries which are available to us around the 4 decades back, the most of the batteries are using the liquid or aqueous solutions as the electrolyte. But that electrolytes has a number of limitations. To overcome that limitations, the gradually research work on the solid polymer electrolytes or the polymer electrolytes. So we are coming to the polymer-based electrolytes. Basically, they are non-aqueous and self-supporting polymer electrolytes introduced by 1973. And polymer is basically a polymer containing salt, acid, ionic liquid, etc., which provide ions to move through the insulating polymer matrix. Although we have some idea of containing polymers, they are electron conductive too. So usually we take the insulating polymer materials and we top some dispersed side, maybe organic or inorganic, and we try to make them good ionic conductor. Polymer electrolytes possess number of intrinsic qualities over the other type of ionic conductor, which the most important are shape versatility, film formation, flexibility, lightweight, electrolyte leakage, internal shorting, use of corrosion solvent, and production of harmful gases, etc. So these properties stabilize polymer electrolytes as potential candidate for use of different applications. Right. So these are a few important properties. We'll discuss these properties in further slides also. So this is a broad classification about the polymer electrolytes. Based on source of origin, we can say natural polymer electrolytes and synthetic polymer electrolytes. Nowadays, so many people are working on the natural polymer electrolytes, which have been taken from the plants or some chitosan, or you can say cane sugar. This all we are getting people are working on different types of natural polymers. Now, based on the physical state and composition, we have broadly classifying the gel polymer electrolyte, solid polymer electrolyte, and composite polymer electrolyte. Now, let me discuss a bit about the gel polymer electrolyte. Gel is it's incorporate both diffusive properties of liquid and cohesive properties of solid as well. And it's a plasticized, or you can say a gelled polymer matrix. Combination of plasticizers result in the polymer matrix swollen liquid electrolytes. The most important property when we are discussing polymer electrolytes are they are high ionic conductivity. They have very high ionic conductivity, and you can say low volatility, and low reactivity. Low reactivity, the electrodes can offer good properties like gel polymer. We will have other slides to compare these all things. And when we are coming with the solid polymer electrolytes, the research in solid polymer electrolytes was launched somewhere in 1970s, and right and all actually discussed the idea of polymer electrolytes. Armand was the first to verify the technology application of solid polymer electrolytes. A dry solid polymer electrolyte based on PEO is one of the important material of polymer material. Our research group are working widely on the PEO, and they have so wider applications. It broadly used in solid-state batteries, solar cells, fuel cells, dye-synthesized solar cells, supercapacitors, electrocapacitors, electrochemical sensors. They have wider case of application. And in spite of this, they have a high activity, high process, mechanical strength, high energy density, flexibility. Again, one of the very important applications in the case of solid polymer electrolytes. And apart than this, the present scenario, the present research is going on composite polymer electrolytes. Solid polymer electrolytes have some limitations. You can say have drawback based on low conductivity, ambient temperature, high interfacial resistance, So the composite polymer electrolytes can overcome all limitations which will be usually offered by gel polymer electrolytes and solid polymer electrolytes. So this is the comparative study from the K. Ramesh paper. This is the common feature which we have in all gel polymer electrolytes and all things. Light in weight, solvent-free, low volatility, low reactive, good operational safety, high energy density, good flexibility. Polymer electrolytes. Other properties like high ionic conductivity in the case of gel polymer electrolytes. High automation process, good mechanical strength will be offered by the solid polymer electrolytes. But in case of composite polymer electrolytes, high thermal stability, good interfacial contact, and again, a high ionic conductivity. If we discuss about the disadvantages or the drawback in case of gel polymer electrolytes, poor mechanical stability is one of the very big drawback in case of gel polymer electrolytes. While when we are discussing solid polymer electrolytes, a big problem is low working conductivity by various processes, but still the ionic conductivity is not appreciable till date. But in composite polymer electrolytes, the conductivity is comparatively high. I'm not saying it's very high. Still, the work is going on in the case of composite polymer electrolytes as well. The ionic conductivity offered by composite polymers are than the solid polymer electrolytes. We have the most important property of polymer related to the degree and density of polymer electrolytes. The crystalline polymer electrolytes have and lead to low ion conductivity. While if we have the amorphous, then we could have the higher ion conductivity. So nowadays we are trying to disperse the various disperse side and trying to get the amorphous phase of the crystalline polymer. Although most of the polymers are crystalline in nature, and while dispersing the salt and other organic and inorganic fillers, we are trying to get the material more amorphous than the crystalline. To improve the ionic conductivity of polymer electrolytes, the major approaches are polymer blends, utilization of co-branch, combi-branch copolymers, incorporation of oxidants and liquids, addition of inorganic and materials. Now, these are few implementations. And already we have discussed. So the main thing is whenever we are using polymer electrolytes for the battery applications, the ionic conductivity of your electrolyte must be high, and it should be compatible with the electrode which have been used for the fabrication of your particular type of battery, right? So the recent research area, this is the we are working on polymer electrolytes to get the high ionic conductivity. This is the ionic transmission across the electrodes through the polymer electrolytes, flexibility and scale, inclusion of the ionic liquids, and safety, again, one of the crucial issues. So I'm a bit interested about the ionic conductivity. So different proposals have been proposed to reduce the crystallinity and improve the ionic conductivity. For example, salt in polymer complex. This is one of the methods. Nowadays, the people are working in polymer in salt also, where the concentration of salt is pretty high in comparison to polymer. Addition of plasticizers, blend with other polymers and all. Recently, Wen and al. Has reported mechanically robust polymer electrolyte is designed using a 8.6 millimeter thick polyamide, and they reported a completely high ionic conductivity of the order of 10⁴ Siemens per meter at room temperature. And another interesting approach to the solid polymer electrolytes was reported by Yu et al. In somewhere 2020 by encapsulating a polyethylene glycol into the covalent organic framework. And again, the ionic conductivity was pretty good up to the order of 10⁻³ but the problem is like this conductivity of the very high temperature. The fabrication of solid polymer electrolytes operate at high temperature due to thermal robustness, lack of solvent residue, and high ionic conductivity. Right? Now, let us discuss. This is all about the theoretical part, which I want to give you the idea about all polymer electrodes and all things. So, this is the work which our group has worked out. And here we have tried to make the mixed conducting polymer electrolyte. Mixed conducting means here we can have the ion as the electronic conductivity in system. And for this purpose, we have dispersed Fullerene C60 into the combination of PeO plus NaI, and we disperse Fullerene into this matrix. Right. Here we prepared for finally the abstract. We got the Fullerene, methyl the structure. This we have prepared in our laboratory itself. We have taken phenolphthalein balls and we collected a soot by burning, and we dissolved the entire soot which we have collected into the benzene, and we spared around 5 to 8 hours. After preparation, we got the fine solution. NMR, we got that the structure which we obtained was methanofullerene, close to fullerene, one of the isotopes of fullerene. And synthesis of polyelectrolyte a very standard solution technique we have used to develop thin polymer films. We have used polyethylene oxide 0.25 gram as a host polymer and 10% of the NaI 0.025 gram of salt we have adopted. And where maneuver ratio was fixed, and PO with NaI is desired amount dissolved in methanol, and we stirred it for some time. But after getting it, we dissolved the so prepared methanol and stirred for long time on 10 to 12 hours. And when we got the viscous solution, we poured into the polypropylene petri dish, and we got the thin film of the order of 200 300 microns. That films are taken into further characterization process. During the characterization process, we did some structure characterization, XRD, AIR, polarized optical macros. We did to get information of the composition of electrolyte and the dissociation. We did thermal conductivity as well. For presentation, I have not involved this DSC. And electrical characterization with impedance spectroscopy, conductivity with weight constant, with temperature, dielectric constant here. In our reverse search group, we are finding two important properties known as concentration of charge carriers and mobility of charge carriers to analyze the reason behind the change in conductivity. Whether to find the reason behind the actual change in conductivity. So we calculate the concentration of charge carrier and to calculate this all parameters, we have used these formulas. If someone wants, and note down these formulas: the dielectric constant, frequency dependent dielectric relaxation, double dash, modulus M prime, M double prime, AC conductivity. Conductivity is X weight percent. And in order to explain the previous about the calculation of the conductivity and the mobility. So these are the formulas which we have used to calculate the charge carriers and mobility of charge carriers, right? And we got very interesting result while we calculated and we compared these values with our conductivity. Now, first study was the XRD, and here you can see that the initial behavior to compare called film, we have used a pure PONA reference somewhere to 20 and from to 8 degrees Celsius. This is at 28 degrees. This is to the PONA complex. Well, when you go to further areas like close to the value of around 3 and which is 40 degree and 45 degree, you can also and this XRD graph is attributed to presence of CST in their own phase. So this confirms the composite behavior or composite nature of the we have in our lab. The same behavior you see in you can see at the where close to this part, this area, you can see peaks can be are visible, which are not visible to your the matrix, not visible to pure matrix. These peaks are actually attributed to the presence of 660 where they are on. They show that never chemical reaction will casting film. So again, reconfirmation of our composite polymer electrolyte films. This is the polymer, and here you can see as we increase the concentration of the dispersite, initially the spot are reducing and the density of the are increasing. So this is again a confirmation. This we correlate when we come to the conductivity part, that how this increases. So this is the conductivity somewhere is maybe around 6.4, I think, into 10 to the power minus 5 per meter. But as we disperse the first 1% of the Fullerene, it suddenly drops somewhere to, I think, 3.4, 3.6, some 10 to the power minus 5. This decrease in conductivity is maybe the increase in the crystallinity initially. But further adding or dispersing the polymer, they start increasing conductivity. You find very high level of conductivity, where up to order of somewhere to 8 to the power minus 5 Siemens per meter. And this change in the variation in conductivity can be explained on the basis of circulation model. If someone want to understand why the fluctuation conductivity is there, then it can be explained on the basis of percolation model. Right now, this is and the concentration of charge areas. Here, you can find that the conductivity pattern, just example with the concentration of areas, that the conductivity of any substance or the material in change in conductivity is because different conductivity. And again, you can say that the dielectric constant is doing the same thing, which is being shown by shown here. So this is the conductivity versus temperature. And as we all knew that the activation energy, whenever energy changes after the temperature around 3 degrees Celsius, and for lower activation energy or conductivity will be high. So we are great for 4 meter half not good in study all samples they have prepared, and temperature after melting, sample showing good conductivity, higher temperature. Now the idea of dielectric relaxation is the dielectric formulation is used in retrieving any particular about conductivity behavior of the material. Dielectric constant is major to stop dielectric constant, and you can say the higher at lower frequency, the polarization of the electrode is very high, because this value shows very high. But as you can see, the periodic reversal of the field becomes so, and the electric field not the charge accumulated decreases, lead to the decrease because of accumulation of the charge output. This value is increased as necessary.
Dr. Amit, the time is over.
Yeah, I'm still. And like the model calculate to overcome the problem and use analyze relaxation in different positions, right? Like system and higher will present height of changes in the part and first consideration get the relaxation. So the idea of the modulus. This is the number. This shows how much in what case they usually express the idea of polyelectric. So in our system, we got the very high the idea of electron transfer 0.2 and conductivity of 6% of 0.87. Right. So finally, synthesis of this laboratory has right as this is dispersed in the polymer matrix and was obtained. Reduction system was confirmed by MR study. They also come and there is no confirmation of reconfirmed the optical micros. The highest conductivity we obtained for 28% of 0.9 to power minus 5 Stephen. Was obtained. Parameters such as charge carrier concentration and mobility has been studied in different concentrations. This is conducted followed by concentration pattern. The relation directly constant frequency is the electro-interface polarization process. And found that crystallization by this idea has been from the study which we did on in our characterization process. So it's about my projection. And recently we are working on the concept of biopolymers addressing some biopolymers from natural substance and even we are also trying to get the biopolymer based DSSCs where it can offer the biodegradable or you can say a fertilizer property in future when we discard the solar cells, the solar cells into it will not be environmental hazard. We can use as a fertilizer also in this area with the polymer electrolyte. We can ask.
Gracias, doctor Amit. Muy bien, estamos sobre el tiempo. Solo podríamos dar lugar a una pregunta. Si no hay preguntas, agradecemos al doctor Amit Saxena por su presentación. Dr. Amit, thank you for your presentation.
Thank you very much.
There are no questions. Thank you for your presentation. Bueno, pues vamos a continuar con nuestro siguiente ponente. Corresponde al doctor Luis Casillas. Buenos días, doctor Luis.
Hola, buenos días.
Gracias por acompañarnos en este tercer encuentro de materiales y dispositivos Altamira 2021. Si me permite, en lo que usted nos comparte su pantalla, voy a leer la reseña de su currículum que nos hizo favor de darnos. El doctor Luis Casillas recibió su doctorado en Ciencia de los Materiales de la Universidad de Tennessee y una maestría en Matemáticas y Física Técnica del Politécnico de Gdańsk, en Polonia. Actualmente es investigador en la Universidad de Linköping, Suecia, donde estudia los efectos del desorden magnético y vibraciones en las propiedades de las dislocaciones de hierro. Sus intereses de investigación son los efectos de radiación y la interacción de electrones modificaciones y fronteras de gas. Nos da mucho gusto tenerlo en este evento. Solo le comento que tiene 20 minutos de presentación y al final 5 minutos de preguntas.
Pues al contrario, mucho gusto de estar aquí hoy con ustedes. Las preguntas obligadas, ¿se ve mi presentación y me escucho bien?
Sí, vemos su presentación